Okay, so today we're going to continue our factoring review of everything that we had done previously. So we talked about two methods of factoring. We talked about our GCF method and our grouping method, and we learned how to solve them. So today we're going to review our trinomial method. So with our trinomial method for this one, at least for today, we're only going to be working with trinomials that have a leading coefficient of 1, meaning they're in the form x squared plus bx plus c. Okay, b and c, they're just going to be any sort of number. Okay, obviously my x's are my variables, and the reason, like I said, the leading coefficient is a 1. I don't have a coefficient in front of the x squared. So we're going to be looking to factor any trinomial that's in this form, any trinomial that has a leading coefficient of 1. So if I gave you a problem to factor something like x squared plus 9x plus 20, and I wanted to look to factor this. Well, what we need to do is we need to look at a couple different things. The first thing I'm going to look at is c, the number by itself, without any variable. And what I want to know is I want to know all of my factor pairs of 20, meaning what two numbers can multiply to give me 20. And I just want to kind of list them all out. So I've got 1 and 20, I've got 2 and 10, I've got 4 and 5, and that seems about it. So once I write out all of my factor pairs, I then ask myself, okay, well, which one of these pairs will have a sum that equals the middle term, that equals 9? All right, so I say to myself, well, when I add these together, 1 plus 20, that's going to give me 21. That's not 9. So that's not the factor pair I want. 10 plus 2, that's going to be 12. Still not the factor pair I want. But 4 plus 5, that equals 9. This here is the factor pair that works, that multiplies to give us C and adds to give us B. So once I find that factor pair, well, then I can just write my answer as x plus, we'll call this first factor that we found, we'll call that m. We'll call the second factor p, just so that we can see where they go. So it's going to be in the form x plus m times x plus p. So I'm just going to replace my m, this m here, with this m. I'm going to replace this p with this p here. So this is just going to become x plus, my m is 4, and x plus my p, which is 5. And then this would be my final answer here, x plus 4 times x plus 5. That's how I would factor my trinomial of x squared plus 9x plus 20. All right, let's take a look at another one. Let's say I had something like x squared minus 8x plus 12. Okay, so again, same concept. I see that this is in the form that's in the form x squared plus bx plus c, no coefficient in front of the x squared, so that's fine. So again, I look at c, and I want to find all of my factor pairs of 12. So what do we have as factor pairs of 12? Well, we could have 1 and 12, we could have 2 and 6, or we could have 3 and 4. But noticing what I want to do, I want them to have a sum of negative 8. So in order to have a sum of negative 8, that means that both of these numbers can't be positive. Both of them actually have to be negative, because the only way to multiply to get a positive number and add to get a negative number is if both of those numbers are negative. So I'm not going to work with positive 1 and positive 12. I'm going to work with negative 1. and negative 12. I'm going to work with negative 2 and negative 6. I'm going to work with negative 3 and negative 4. But I am going to do the same thing. I'm going to add them together. So negative 1 plus negative 12, that's negative 13. That's not what I want. Negative 2 plus negative 6, that's negative 8. And that is what I want. I wanted to get negative 8. So these are the pair, or this is the pair that I want to use. We're going to call the first number m. The second number is p. So again, it always goes in the form x plus m times x plus p. So my answer here is going to be x plus negative 2, but remember, we never put plus negative, so it's not going to be plus negative, it's going to be minus 2. Same thing over here, it's going to be x plus negative 6, but plus negative we don't ever put, so it's just going to be x minus 6. And that is going to be my final answer. That is the factored form of x squared minus 8x plus 12. Alright, so I put two trinomials here up on the screen. So again, pause it, take about 5 minutes, see if you can solve these, or sorry, not solve, factor these two trinomials. Now the first one's pretty self-explanatory or straightforward here, but the second one, just kind of pay attention. It's not in the form x squared plus bx plus c. We have to rewrite this into standard form. Hopefully you remember what standard form is. But that's your little hint for the second one. Rewrite it in standard form first, and then go through the process of factoring. So again, pause it here, take 5 minutes, try to factor them, and then unpause. Alright, so hopefully we see now that we have the correct answers here. For the first one, it would be x plus 3, x plus 8, and actually I didn't even realize this. I should be using the correct variables here. Oops. I should not be using x for this. I should be using d, because that is the variable that I start with. So just kind of be careful about that. Obviously, I made the mistake, and it's very easy to make that mistake as well. For this one, it would be m. So again, just kind of be careful about that. But as we see here for the first one, we want the factor pairs of 24. So you have 1 and 24, you have 2 and 12, 3 and 8, 4 and 6. But when I add them together, I want it to be positive 11. So I do know that both factors have to be positive. 1 plus 24 gives us 25, so that's not good. 2 and 12 is 14. 3 and 8 is 11, and that is the one that I want. So 3 is my m, 8 is my p. I plug them in, and I should get d plus 3, d plus 8. Now for the second one, I gave you the hint to make sure that you put it into standard form first. Remember, standard form is highest degree down to lowest degree. So the m squared, that's the highest degree. This has to go first. The negative 22m is then the next term, so that is second. And then the positive 21, that has the lowest exponent of the lowest degree, so that would be last, plus 21. So I'm looking for factor pairs of 21, and I do get, if you just work with the positive, I would get 1 and 21 and 3 and 7. But I realize I need to add them together to get a negative 22, so that means I've got to make both of them negative. So it's a negative 1 and a negative 22, or a negative 3 and a negative 7. Well, when I add them together, negative 1 plus negative 21, that gives me negative 22. Negative 3 plus negative 7 gives me negative 10, so I'm definitely using the negative 1 and negative 21. This is my m, this is my p, so it's going to be m minus 1 and m minus 21. Okay, so let's try a couple more here. Again, it's really the same concept, but let's say I had the problem x squared plus 2x minus 15. So again, I'm looking to factor this trinomial, so I am looking for my factor pairs of negative 15. So here we have to realize that this is a negative 15. So when I multiply two numbers together to get a negative number, one of them has to be negative. So my factor pairs are actually going to be -1 and +15. Or it could be +1 and -15. You actually have to use both of them. Okay, I could also have 3 or -3 and 5. I could also have +3 and -5. All of those work. Well, now I have to say, okay, well, which ones will add to be +2? Well, -1 plus 15, that's 14. 1 plus -15, that's -14. -3 plus 5, that's 2. And 3 plus -5, that's -2. Obviously, I want the +2. So these are going to be the pair that I'm going to use. My first one will be m. My second number will be p. So when I write this out, again, it's x plus m, x plus p. So it's x plus -3, which becomes -3, and x plus +5, or just x plus 5. And then that would be my final answer. So we just have to pay attention to the signs in front of these two terms. Obviously, if we're multiplying to get a negative number, only one of the two numbers can be negative. When we're multiplying to get positive, both of them have to be positive, or both of them have to be negative. All right, let's do one more together. Let's say I had this one here, x squared minus 7x minus 18. So again, I want to find my factor pairs of -18. So I know that one of the two numbers has to be negative. So it could be -1 and 18. It could be +1 and -18. It could be -2 and 9. It could be +2 and 9. It could be -3 and 6. It could be +3, that should be a -9, sorry, and -6. And it looks like that's about it. So those are my possibilities. So now I have to go and say, okay, well, which ones will add up to be -7? -1 plus 18, that's 17. 1 plus -18, that's -17. -2 plus 9 is 7. 2 plus -9 is -7. -3 plus 6, that's going to give me 3. And 3 plus -6, that's a -3. So obviously, which one will add up to be -7? That's going to be this pair right here. That's the only pair that adds up to be -7. So my first one, that's m. My second one is p. So again, it always goes in the form x plus m, x plus p. So this is going to be x plus 2, because we have a +2 for m, and x minus 9, because it's a -9 for p. So that would be my final answer. So again, here are two more problems that I'd like you to try on your own. Pause the video for about 5 minutes. Do these, factor them, and unpause and see if you get them correct. Okay, so for these two problems, for the first one, we should have gotten y minus 3, y plus 16. When we do our factor pairs of -48, there are a good amount of them. But if we list them all out, we realize that the factor pair that multiplies to get -48 and adds to get +13 will be -3 and +16. So my -3 is my m, that's why it's -3, and my 16 is my p, so it's +16. For the other one, we want -24. So again, there's a couple of them, but we want it to add to be -2. So the only one that adds to be -2 would be 4 and -6. So 4 is my m, -6 is my p. I put the 4 plus 4 here. It's going to be -6 here. And that's where I get my r plus 4 and r minus 6 from.